All right, so today we are going to be looking at a blinking LED circuit. First, you start with the 9-volt battery, which goes into two resistors that act as a voltage divider. Right now, this is a 9-volt battery, so theoretically it should be 4.5 that gets output. That's output from these two resistors, but we read 8 volts from the battery, so it's 4. This goes into the first op amp, which is a inverting amplifier with a capacitor and a resistor, which when the capacitor is not charged, just simply goes straight to the transistor here and lights the LEDs. However, there is this right op amp which acts as a non-inverting amplifier and amplifies the input from the voltage divider and charges the capacitor. When this capacitor becomes fully charged, it opens and then starts to discharge. This means that once it's open, this means that this op amp does not send voltage to the LEDs, and at the capacitance or the resistance, at the capacitance at which this discharges is how the LEDs dim and brighten. If we had a larger capacitor, there's more voltage that it can soak up, so it takes a longer time for it to charge and discharge, or brighten and fade. And that's how an RC circuit works. And so you can do the same thing if you choose a higher resistance, because then that means it takes a longer time for less voltage to charge this same capacitor, and then that would mean that it takes a longer time for this to fade and illuminate again. And that is how this blinking LED works.